Thank you, thank you, thank you, thank you, thank you. All right, so let's rewind back to December 2021. Imagine yourself, you're standing there, and welcome to 2021 Wrapped. It's the single biggest Spotify campaign of the year. It's the biggest by numbers, by engagement, by budget, by amount of people involved. And it's also a way for us at Spotify to present data in quite a cool way. Or as one tweeter once put it, Spotify is the only tech company to figure out how to successfully rebrand "We've been tracking you" to "Isn't this fun?" Because it is fun. We are Shayan, Mindy, and Lekha. And for the second half of 2021, we were the data engineers on this project. And this talk, we will take you behind the scenes of what building data pipelines for Wrap really means. And we will also want to highlight one thing, and that thing is that you are engineers sitting here, and engineers who want to work on important products, and you want to be a damn good engineer while you're doing that. Engineers usually want to get to the heart of things, and you want to work on stimulating products and exciting ones. And we feel like that the opportunity to do that is right here. We saw the opportunity to work on an impactful project, and we took that opportunity. The opportunity here was to build pipelines at a truly large scale. It's a huge one. We're talking about billions and billions of data points, and these data points power every single user's Wrapped experiences. We also want you to think about how you can apply some of our learnings in your project, so please have that in mind. But we also want to highlight one thing we find quite valuable as engineers, and that is the growth aspect. And why will we talk about growth? Yeah, because we weren't data engineers when we started this. We were backend engineers that were embedding on this project. Yeah. Hi. Embedding is a way for us engineers in Spotify to hop on another project that's not our home team for a specified amount of time. And we want to highlight to you that there's always a time and place for growing and evolving new skills, especially while embedding, no matter how big that challenge might look like. So don't let that challenge be an obstacle for you. Let it be the motivator to try that on head first. So how does it all start? How do we go about from applying for this role to getting the data out to the users? So at some point in the summer, a group of people, embeds, are all joining together from all over the organization, coming together as strangers. And our mission was quite simple. We, as a team, want to go from an idea of a story into this very specific part of the app that's part of the Wrap experience, like this audio aura, for example, that was part of 2021 Wrapped. We had a few months, the last half of last year, to figure that out. Two things happen in the beginning. First off, we have some ideas from brand and creative, and then we also have our own internal brainstorming process. And brand and creative, that's part of the organization that deals with a lot of cool creative ideas, and they had a big input into Wrapped. For example, designing the content of the stories. And on top of this, we have our own little brainstorming sessions where we as a team, engineers, data scientists, product managers, we can brainstorm our own ideas and figure out what we would like to see in the app in December when we open up Wrapped, which is quite cool. All of these are then constrained by the question, what data do we actually have? So then our data scientists come into this. They make the magic. They prototype the stories. They figure out how can we represent the data we want to see. So for example, how many users are going to be able to see it? Can we try it out ourselves in the team and figure out like, hey, this looks like a cool story. Or if something sticks out in the data, like, hey, why is horror punk the top genre globally? The prototypes are SQL queries to our internal Spotify datasets. Then we also need to make sure that the data is recognizable, that it's relevant, that it's accurate, that it will be spot on for all users. Because raw data is not necessarily the same thing as intuitively accurate data, what feels right. Just because you listen to rain sounds to fall asleep the whole year doesn't mean that your favorite artist is sounds from the Amazon rainforest, for example. A user wants the data points to feel like it actually represents whatever you listen to during the year. And we cannot really A/B test rap, so we cannot really figure out if users like this or not. We only have one shot at it, and that's when the campaign gets out. So here are lovely data curators. They are the experts in the loop. So they are the key for our quality control to answer questions like, what is the definition of a rain sound? How should we categorize podcasts? So they should show up or they shouldn't show up. We just used spreadsheets during the whole last half of the year, during the whole project, back and forth, just to figure these kinds of things out. We kept it quite simple. And then there's also a continuous feedback loop between this, where data creators feed into what data scientists are prototyping. And we need a method of offline testing, a method so that testing is happening continuously, so that we're trying out our own product while we're developing it. It's a continuous loop, and I will touch later on this subject of learning through trying, because we're really trying it out so many times. Again, we only have one shot at it. And then, after having a nice prototype, here comes the data engineering part. And thanks to our tight collaboration through this whole process, and we've been like into it, it really, I mean, theoretically, it really should be to just translate SQL code into SHIU code, into data engineering pipeline code. And it sounded easy to us until we started to run things, and you run into errors, and you run into so many errors. You need to put out so many fires. And we, as a group, needed to understand that data engineering is as much engineering as it is about the data. And it is through the engineering part that our true growth learnings came. Yeah, so that's the whole process of the development. And let's get to the cool stuff. How did we actually build the pipelines? What is the architecture, and what can you learn from this? Oh, you have one.
Hi. Yeah, so like Shayan was saying, we quickly found out that it's as much about the data as it is engineering itself. So like as we got accustomed to the new systems, we discovered that certain decisions were made, and there are certain problems that previous engineers had been solving for. So before I go into like the architecture, my hope is for all of you to kind of see what kind of learnings we got from this experience, and also see how maybe you can apply it to your own day-to-day work. And also, to see what can we actually learn from this whole experience. So at first we thought, it should be pretty simple, right? You take the data, you stick it in a pipeline, you get the output. It should be pretty simple. But actually, it's not that easy. We can and did run into errors. And this is where we get into like the fun engineering problems. We can see like, how is the architecture set up for moving like terabytes of data for all Spotify users, into seeing how did we get that to get actual data to work. So to answer this question, we have to start from the beginning, which is where does the data come from? So when a user listens to music in Spotify, Spotify stores data that helps power features in the app, and this is through things like powering personalized playlists or making music recommendations. So you can imagine that having a whole year's worth of music listening for over 400 million users ends up being a ton of data to manage. And actually, this is where we get to our first interesting challenge, which is how do we handle this huge amount of data and make it into something workable? And luckily, this is something that the three of us didn't have to tackle ourselves, but the engineers before us, the decisions they made were pretty impactful with how Wrapped is currently set up. And these previous smart engineers, they transformed this data into what we call listening aggregates, and they set up the architecture for this. And the key here is they're trying to figure out how to get this huge amount of data and make it into something that is workable. So as you can see, we have the daily data, which is about a terabyte for the entire year, and each user's play history is aggregated into then a monthly set. And this is something that is done to make it like more easy to manage and also to reduce the data a little bit so it's more workable. So when you work with distributed data, one of the key things you have to do is group together by a key, which is known as shuffling. And this ends up taking a lot of time and is actually something you want to reduce as much as possible in order to optimize your jobs. So what these engineers did was they used SMB, which is an efficient technique for reads and joins, and it lets us skip the shuffling step, which greatly improves our performance. And later on, we'll touch more on SMB, but this is something that's like pretty interesting, and we have, I think, sources on our public GitHub page if you want to read more about it. So in previous years, the wrapped engineers would have to actually handle this whole step before, but since then, it's been platformized to another team, which actually hands it to us. So now that it's off to this other team, they just kind of deliver it to us in these already nice, neat, monthly aggregate partitions. So when we receive this data at that point, what we're going to do on the wrap team is we just go ahead and stick it all back together. And the reason we do this is for wrapped, you want the whole entire year of data. We don't want just a month. But at this point, you might wonder, why did they give us the data in months instead of daily or even yearly? Well, daily would be too granular. And as Shayan mentioned, the wrap team is assembled halfway through the year. So we need data to test and work with, and a month is just like the right size that works for us. So we can still work with the data even as it's coming in throughout the year. And this also allows other teams at Spotify, and not just the wrap team themselves, to test out the features. So one other benefit is that with the monthly aggregates is that the power comes in the data being delivered in SMB, and this is using the monthly SMB data sets. So the power of this is that we can now parallelize the reading in all the months at the same time and then aggregate it into this yearly aggregation job. So to, recap, as we're moving along and getting a year's worth of data, we then take that data and aggregate it at the monthly level. And then from the monthly level, we aggregate it then into a year. And this answers the first part of our original question of where does the data come from, which is the user's data. So now we get to the second half, which is the metadata. And what do we mean by metadata? So this is information such as information about the music in the podcast. So for instance, is the song that I just listened to, is that considered sleep music or is it study music? This data is available to us from various teams at Spotify. So then at this point, we now have two of our data sources, which is the user data and the metadata. And this feeds into probably the single most important job in our pipelines, which is what we would call our source of truth. This is the job that is an input to all of the user data stories that powers what you see in the app itself. And this basically provides all the information that we need for our data stories. So from here, we now have, anything that we could ask for in this source of truth job, and we can now build and implement the actual SQL logic into Scala code and bring the data stories to life. So then at this point, we would then store it into a key value database, and at this, we're done with data. Once it's stored in the database, backend will go ahead and take it. Take the data from there, they'll do their own things, and then they'll send it off to mobile, which will then render it, and as you can see, we then have wrapped, which is wrapped, all the stories. So at this point, we have all this data, we've run all our data story jobs on an employee subset, and we've validated that everything works, and you can actually see it in the app itself. So at this point, we should be ready to ship everything, right?
So we have our architecture in place. We've written all the code, run it on employees. So far, so good. Everything works. Now imagine you're 1 month away from Wrapped launch, and we are ready to test this for Spotify scale. We are doing this exercise with 3 main goals in mind. Number 1, does it scale? Do our pipelines run with a reasonable cost and time? Number 2, is the data accurate? So far, we've been testing on employees and on smaller samples of users, but we want to make sure we don't have a bug in our pipeline because of which horror punk is everyone's top genre. And finally, number 3, what is our launch timeline? So we have over 20 jobs that run to power Wrapped, right from yearly aggregation, enriching it with metadata, each individual story being computed, and then uploading all of this data to our key value data store. we want to know how long it takes from the time we trigger our first job to when we can have wrap data ready to launch. So, of course, we're 3 backend engineers here masquerading as data engineers. We've never tuned a job of this scale before. How do you approach an exercise like this when you're doing it for the first time? We kept it simple. Wrapped is a one-off pipeline, one-off situation, which is a bit different from other pipelines that run in the company, which tend to be scheduled and they tend to run daily or monthly. So some of the tooling at Spotify doesn't directly translate for the wrapped use case. So we kept it simple. Let's create a spreadsheet. Let's note down one job after the other, note down what configurations you ran the job with, and observe what was the runtime of that job, and look at the monitoring and identify, did the run look healthy, or were there any bottlenecks? Is there something we want to optimize? And we started off with our first job. Now, it turns out things got fun right at the very first job, so we're going to do a short case study of what happened there. This is the yearly aggregation job that Mindy was talking about earlier. This job takes 12 monthly partitions of monthly listening aggregates, puts it together, and writes the output both in cloud storage as well as in SQL for our own debugging, and the input comes in SMB format. Now, we haven't triggered an all Spotify user base scale job before. We have one baseline. We have one baseline from before, which is an employee run on a few months of input that ran with over 500 workers, and it took around 7 hours to run. So our first run we trigger with kind of the same configuration, and let's see how that goes. Well, turns out this kept running for around 25 hours, and we had to manually terminate this job because something clearly looked off. We have, of course, started borrowing help from other more experienced data engineers in the company, some of which are in the room. Thank you for your help. And together, we are really digging into this job and trying to look into what was going on and what was happening and how can we solve this bottleneck. So let's make a few observations from that job. The first observation was that the throughput of this job was steady, which is great, but it was very low, so something's clearly off. The second observation was that only 16 out of 512 machines were really doing anything when you look at their CPU utilization. Third observation, the SMB parallelism, which is something that you see in the logs when you run your job, was 512, and we're going to see in a minute what this exactly means and why this matters. And the fourth observation was that in the logs, we noticed that the read step of the SMB input was being retried multiple times. So, okay, putting these observations together, we've started forming some hypothesis of what might really be happening. Now, looking at the logs specifically, other teams have seen these logs before, and it was pointed out that this happens sometimes when the cloud storage that you're reading from has some upper limits to how many files you can read at the same time. And the underlying cause of that is that the parallelism of your job is too high. Now, what you can do in this scenario is try to reduce the number of machines running or try to reduce the number of threads running per machine. Okay, makes sense. We try some of that out. The other thing that you can do in this scenario is you could reduce the number of partitions in your input. But we already have only 12 partitions, whereas other teams facing this kind of situation, it's been in the case of like 700 input partitions. But we try some test runs to kind of validate these hypotheses. They don't really lead us anywhere. Now, the second line of thought, looking at all the other observations, was that your parallelism could be too low. One thing you could do in this scenario is you could set in your code explicitly what parallelism you want your job to run with. Okay, we try that, but it doesn't really improve anything. The second thing that you can do is you can try increasing the number of files in your input. Okay, this idea makes sense, but what that means for us is that the other team that generates the monthly partitions for us, they would need to regenerate all of their data with a different number of files per input partition, which means they would need to rerun all those jobs with different configuration. So we've asked them to do that for us at this point. And while we wait for their pipelines, of course, we're So we're waiting. It takes some time for them to rerun. Now, while we're doing that, we're a few weeks away from wrapped launch. We still don't have a job that scales and finishes. So we're getting a bit introspective and looking at our code, saying, what can we remove from this? Is there something that's not really essential that we can just get this job to finish? One thing that stuck out was that we're also writing to SQL, and that was primarily for our own debugging, not really to ship wrapped. Let's get rid of that. And at that point, we at least get the job to crawl to a finish. So it's not a performant job, but at least we can ship wrapped, which is great. In the meantime, our neighboring team has now rerun some of their pipelines, and they've started reproducing some data with a different number of files per partition. So we've started running some experiments with the new input data. So our baseline on a test run, if you have 512 files per partition in your input, if you trigger it for 1 month of data, the job takes around 2 hours. Double the amount of files, jobs takes half as much time. If you take the amount of files all the way to 8,000, if my clicker helps me, then the job takes 10 minutes. So, okay, so we have a winner. We've figured out a way to dramatically speed up our job. Firstly, let's put it together, and what did we do? We started with this job. Firstly, we reduced the number of files. We increased the number of files per input partition from 500 to 8,000. And secondly, we removed the writing to the SQL output that was really for our own internal debugging and not to ship. And putting that all together, we had a job that didn't scale and that ran for 25 hours and didn't finish, and that job came down to a little over 2 hours. Now, as engineers, we want to understand really what's going on and why does all of these changes make such a huge difference. So to understand that, we need to understand how SMB really works under the hood. Now, let's take a simple example. Imagine you're trying to join together January and February, 2 partitions. Each of those partitions contains only 3 files each. The way SMB works is that it creates a hash of the key that you're trying to join together. And if a certain key is present in file number 1 in the first partition, it'll also be in file number 1 in the second partition. So what that gives us is that you can have a single core of your job, read file number 1 from both sides, put it together, and put it in the output. Similarly, core number 2 can read file number 2 from both sides, and core number 3 can read file number 3 from both sides. And of course, this happens in parallel. Can you speed this up by throwing more machines at it? Turns out you can't, because you can't split the atom further. But what you could do to speed up your job is increase the number of files in your input partition, because of which your job can now parallelize better and scale better. So we've repeated this same sort of process of trying to tune each and every job, run it one by one, observe how it went, optimize bottlenecks when we found any, and in the end, we reached a total runtime of 39 hours for all of our app jobs, and we reached a point where we were confident that we could run all of our pipelines at scale, and we could ship wrapped when it is time. And as backend engineers who are now doing data, we came out with a few basic principles of wisdom on how to tune any data job. And it really boils down to something very simple, very obvious, no matter how complex your job is. Make your data smaller, split your data up. It all boils down to that. If you're using SMB, it's the balance between how your files are sliced up. If it's joins, it's really important the order in which you do your joins, and if there's data in those joins that's not really used at a later step, you might want to get rid of it early. Sometimes it's about getting clever and eliminating joins and trying to broadcast data to different machines and so on. So it could be different tips and tricks depending on what technology you're using and how you've architected your job. But at the end of it, even at this scale, it boils down to making your data smaller and splitting your data up. And beyond the data engineering, sometimes question the requirements, see if there are things that you don't really need that you can get rid of, and approach all of this as a science. Experimentation is a science. Make observations, form hypotheses, find ways to test those hypotheses and eliminate or validate ideas. And that's really the secret to how to do an exercise like this. So at this stage, I think we're ready to launch.
Then comes release day. At December 1st, 2021, we released the playlists, and the stories. We got every single stat delivered through this process of experimentation. They're having a party over there. I'm sad I'm not invited. And then Spotify Wrapped was everywhere. It was trending. And all that hard work had two types of payoff. One is our own growth, engineering-wise, and the second one is a successful product. And my personal favorite part of it trending and it being like on top of everything on that release day is that it shows how much a product can drive internet culture, and it shows how much our product can drive internet culture. And one of my favorite parts of that was all the memes that were like based on top of Wrapped, because imitation is the, what do you call it? Imitation is the sincerest form of flattery, Oscar Wilde said. Now, back to growth again. Now, this is a journey. Well, every problem we do as engineers, they're also a journey as well, and we're learning from it. And we notice the key result from building a product like this isn't necessarily the product itself. It's all the little small tweaks and details that forms your learning while you're doing it. It forms your learning behavior, like how we learned how to tweak a data pipeline. We did it while we were doing it. So, as I told you in the beginning, you want to work on important products. You want to be a damn good engineer. There are opportunities for you to take that, and every step on the way is a learning opportunity to kind of tweak your experience in that field. Slow but steady progress. So let's wrap up what has been said in this talk. First off, Wrapped is huge. We showed you how huge it is. We showed you how many data points it has, but it also has a huge impact on users worldwide with the data we do. So many users that see this. Second off, split up your data as a data engineer and you're working on, especially if you're working on SMB stuff. It makes everything easier if you're not working with one big file that you base everything off, that you can't parallelize. Thirdly, experimentation is a science. Approach it like a science. For every tweak you make, imagine that that tweak is a hypothesis you want to validate if it works or not. Because it's not easy finding the perfect solution. It's kind of impossible to find a perfect solution, but having the patience and doing it step by step, that will guide you to at least know in the right direction which path you're going to take with your code. And lastly, our fourth point, don't let inexperience be an obstacle. Especially if it's an experience in one specific field, let it be the motivator to jump on that project. Because in the end, you will learn two things. Well, first off, you will learn the engineering skills involved when you're jumping on. But second of all, you will also learn how to make it easier to jump on the next project and the one after that. Because this isn't the only time you will embed. This isn't the only time you will switch fields. This isn't the only time you will try on something new. So every learning opportunity itself is also an opportunity to learn how to learn. It's inception, but it kind of makes sense. So in this way, you will know how to approach further learning opportunities. Learn by learning. With that being said, we want to say thank you for coming to our talk and listening about Wrapped.